Understanding access control lists. Yep, that is the objective of this nugget, and actually the sole objective. We're going to divide access control lists into 3 separate nuggets because the topic is so big. First off, here we're going to talk about what they are and what they do. Next nugget, we're going to get into standard access control lists and their configuration, multiple scenarios there, and then extended ACLs and their configuration, multiple scenarios there. Here are your do I know this already questions, so review those. If you know them, move right along. It's very common for the name of something to describe what it does. As I'm talking to you right now, I'm looking out my back patio window at my house, and I see some lawn chairs sitting out there. It describes them. They are chairs that sit on the lawn. I see some screwdrivers on the wall. They are drivers of screws, right? They drive them in. I see flip-flops. I guess that principle doesn't always apply. I'm thinking they are flops that flip. Anyway, it doesn't always apply. Well, actually, that works for this, right? You're going, where are you going with this? Access control lists, ACLs, right? You would think just by hearing that, you go, oh, I know what that does. It is a list of some kind that controls access, right? Actually, no. They are not a list that control access at all. And I know some of you that may know what ACLs do are like, whoa, wait a sec. Yeah, well, it could be. Well, that's true. That's one application of them is when you apply them in a certain way, they can control access. But I believe the name to be totally misleading. I think Cisco should have named them something like IP address identifier or list of IP addresses or something to that effect, because that's really what they are. They are a list, that's it, of permit and deny statement. Think of a big piece of paper, right? And you go on there and you say, okay, the first thing I want to do, item number 1 on this piece of paper, I want to permit 192.168.2.50. I want to deny 192.168.1.0. /24, the whole subnet. I want to, number 3 on this paper, I want to permit TCP port 80, that's web surfing, for the IP address 200.1.1.1, and down and down and down the list goes. It's just a list of IP addresses and statements. Now, I know you're going, well, Jeremy, it's an access control list because I see it says permit and deny. I mean, doesn't that control access? Nope, it doesn't at all. It really depends on how you apply it. Now, if you apply it for access control, how do you do that? I mean, you create this list of statements, and then you go into the, we'll just say a router, and go under the interface, and you say, I want to apply that list, and they're given a number oftentimes, that list number 53 to this interface in the inbound direction for traffic coming into the route. Then, okay, fair game. Yes, then they are access control because it says, okay, are you this, are you this, are you this, because then I'm doing exactly what it says. But wait, I can apply an access control list for NAT. Now you're kind of like, well, NAT, what does NAT do? Well, NAT translates public to private. So I have a private subnet over here. Maybe it's the 10 network. And out here I have 200.1.1.1. Well, in this case, I can apply an access list to say, okay, these addresses are permitted to enter the NAT process. These addresses are denied. Now, does that mean they're dropped? No, not at all, actually. Matter of fact, you might deny them from NAT because there's a network over here of some sort that you want to reach without NATing that. Or actually more common, you're like, well, why would you do that? No, more common is actually you have a VPN. A VPN connection that uses the internet, so you have to go through the router to get there. However, we want to, we don't want to change the address. We want the other side of the VPN to see the 10 address that this is coming from. Well, then I want to deny it from NAT, so I'm not allowing or denying traffic from getting through. I'm allowing or denying the NAT process. Or what about this? Quality of service, right? Quality of service means that I go in there and I say, I want to permit this to be prioritized, right? This one I'm going to deny from prioritization. So it'll still go through. It's still quote unquote permitted. However, I'm denying it from entering the priority process. So maybe it won't be processed first, or it'll kind of get the back seat to some voice over IP traffic that's going through. You get the idea. So an access control list is not for access control. It is just a list of statements that really just list IP addresses and whether they are permitted or denied. I even think maybe a better way of saying it would have been positive or negative. Like I would say positive 192.168.2.50, negative 192. So because that way it takes that access control mindset out of it. We're just saying this, or maybe match and no match. You get what I'm saying, right? That's all there is to an access list. Now, I also want to take a moment to emphasize before I get into this next slide that this is why ACLs are so important, is because there's so many different configurations on a Cisco router that use ACLs. So I don't want you to be surprised when you get in there. You're like, oh, well, why are they having me configure an ACL for this? Well, anytime you want to identify certain IP addresses, an ACL typically steps on the scene. So I just said, they're not for access control. However, that is one of the more common uses for an access list. So what you do when you set up an ACL for security is you create your list of statements. Now, the list is identified by one of two things. I would say first is a number. You could say, I want this access list to be 53, like I was just saying before. So every statement that you put in there, you would say, the actual syntax is access list 53, and then we would say permit 10.1.5.1, right? Access list 53, deny, access list 53. So as you type them in, you're actually building this list. Now you can do a show access list at any point and see everything that's going inside of that list. But you can keep adding more and more and more statements to that list as you go on. You can have an access list, and I've seen them commonly, of 100, 200 different statements. But you also have to realize you want to think efficiently when you think access list, because every line that you add to that access list represents more processing the router has to do for every packet that goes through it. So do what you need to, but don't be messy with them. So when you're using them for security, like I have right here, you create this list, and this is actually done in global configuration mode of your router. Doesn't do anything. You can create them all day long until you actually apply them. And in this case, when you're applying them for security, you go, as I mentioned, into interface configuration mode. You actually use a command, IP access group, and I'm talking about iOS-based routers right now. IP access group, and then you choose your direction, outbound and inbound. And can I tell you, that'll be one of the hardest things. I don't want to predict it for you, so I kind of like curse you to it. But for most people, that's one of the hardest things to learn when you get into access lists is what direction they go. And also realizing that this is one of the fastest ways to devastate your router is apply an access list in the wrong direction. Because if you do, it starts processing these in the wrong direction, and you may end up blocking the entire interface, since the right IP addresses are not going the right way, or you know what I'm trying to say, right? We're facing the wrong way. But when you apply this, it's just like putting a guard sitting there on the interface of your device. And now let's say we apply it inbound, right? That means every packet that comes in Fast Ethernet 0/0 has to go through this guard. And he looks at his list and he says, okay, little packet trying to enter this router, are you 10.1.5.1? Little packet goes, no, I'm not. Are you 192.168.1.50? And of course he furrows his brow when he says that, because he knows he's going to, no, I'm not. Are you 172.30. Anything? You can see a little /16 here. So anything starting with 172.6, and he goes, oh yeah, I'm 172.30.1.53 is my IP address. And okay, well, come on in, little packet. You're welcome here because you've matched my permit statement. Next packet comes in, goes through the same process. Are you this? No, I'm not. Are you this? No, I'm not. Are you this? No, I'm not. And the list goes on and all the way to the bottom, where if you are not allowed, you will be denied. That is, one of the rules of an access list is there is an invisible, as you know, don't see it when you do a show access list command, but it's there, invisible implicit deny at the bottom of every access list. And that changes the rules of the game. Because what's a router do by default? Let's say this is Fast Ethernet 0/1. If a device wants to get from here to here, it does it because it's a router. It's not a firewall. It's not doing this. But as soon as you apply an ACL, those rules change. It says, I will route you if and only if you have been permitted. Otherwise, you will absolutely be denied. It turns it into a type of firewall. Now, that's easy to overrule. If maybe you've just got a couple IP addresses that you want to deny out of the group, and then you want to allow everything else, you can always go in there and say permit all. Now, the implicit deny is still there. However, as the packet moves down and hits that permit all, one of the things that you'll want to know in your rules is that the packet will stop at the first match. It reads it from top to bottom. As soon as it gets mapped, like if it's 10.1.5.1, then that packet does not go through any more processing. Because of that, Cisco recommends, and because of just good design, to put your more specific lists or specific statements at the top of the list. Think of it this way too. What if I have an IP address who was doing something they shouldn't be doing. 172.30.1.10, right? This guy. And I'm saying, oh man, that guy's denied. And so I squeeze him right down here, right before the, well, I'll say right after the statement. Well, if it's processing in order, if this guy comes through, it's going to say, are you this? No. Are you this? No. Are you this? Yep. And then it never reaches your deny statements, your more specific ones. So that's why the more specific ones typically go at the top of the list. ACLs are applied to an interface, inbound or outbound, and I've already mentioned you can use ACLs for all kinds of other possibilities. Last thing I want to talk to you about is the kinds of access lists that we can have, standard and extended. There are more, actually a lot more than what I have here, but these are 99.9% of the time what you end up using. Standard access lists are very simple. They match only on source address. So I can say permit 5.1.1.1, deny 2.1.5.3. Essentially, let me also add one more in there just to make sure you catch it. Permit 10.0.0.0/8. You can do subnets, you can do individual IP addresses. It's all kinds of different ways that you can do that. Now, the question I would have if I saw this list of statements that somebody created, I'd say, well, permitted to do what? Or denied from doing what? What does this mean? Well, it gains its meaning based on where you apply it. Now, standard access lists, because they're so far sweeping, aren't usually applied to an interface. I mean, if you have a router and a WAN link here, you won't usually go in here and say, I'm going to apply this access list 10 in the inbound direction, right? Because if it says 2.1.5.3 is denied, that means they're denied from everything. So they can't even come in that interface if they're, let's just say, sitting over here. They're denied from everything. So, I mean, if that works for you, then great, use a standard access list. They're lower on processor utilization, but more so, this is typically used for a lot of the other uses of access control list. For example, you could take this access control list and apply it to the VTY lines of your device. Now that's a killer use because it filters it just to a certain purpose, right? Telnet and SSH access, that's where it works very well. You could take this and you could use it to identify what addresses go through the NAT process, right? Because maybe you just want to say, those guys go through NAT. It doesn't really, you don't need a source destination often for that kind of thing. Or, you see what I mean? It's good for identifying them for certain things, but not usually used in a security way. Extended, on the other hand, used all the time for all kinds of things. Extended access lists match on a variety of criteria: source and destination address, protocol, source and destination port number, and the list goes on. You could say time range. It matches on quality of service marking. I mean, there's just so much that you can match on. So, give you an example. I can say, let's go back to my little network scenario, that 10.1.5.9 is denied. So I would write it something like this: denied 10.1.5.9 from using the TCP protocol. If we're actually talking syntax, it goes right there. Denied TCP from 10.1.5.9 to access any destination using a port number equal to 80. Right? What does that do? Denies them web access, right? They can't surf the web, at least using HTTP or TCP port 80, because this source has been denied from going there. Now, wait a second. Just creating that statement doesn't actually do anything unless I apply it. So I might apply it inbound right there or outbound right there. And we'll have a lot of discussion when we get to the configuration on the best place to apply it, because either one would work. You know, as this guy is coming through, it would say denied 10.1.5.9 from even getting in or from going out. Same result, right? Wrong. From Cisco's perspective, you want to be more efficient. You want to apply extended access lists as close to the source as possible. Why? Because it keeps extra routers from unnecessarily processing that packet. Even this one router, if it had to come in here, the router had to look it up in the routing table, figure out where it's going, and then it goes outbound just to find out it's denied there. Why not just deny it from the inbound? I mean, if Disneyland is closed, why drive to California to find out that it's closed? Just give them a call before you leave, as close to the source as possible, and make sure that you know that they're closed. These analogies just come to me. Sometimes I'm like, I think that was brilliant. Other times, well, I'll let you determine that one. Higher processor utilization because there's more that it looks like. And I will say this syntax takes some time to learn. Don't worry when we get into the syntax, the configuration of these access lists. If it takes a little bit for it to soak in, this is almost like subnetting. Not quite as bad. But in my experience, students initially coming in are like, it just takes some time to soak in. Okay, there's one more. We probably won't configure it in here, but it's out there. Reflexive access list. This is what makes your router kind of like a firewall. Meaning, if you have any experience with the Cisco ASA firewalls or any firewalls, typically they use what do they call it? They use it's not NAT. It's not. It's anyway, you essentially define privilege levels, and you say, okay, this is a privilege level of 100, high privilege, and maybe the internet connection is a privilege level of 0. It's going to come to me at any moment. By default, it's going to allow a higher privilege to access lower privileges, but it will not allow those to come in because it's a stateful packet filter. That's what I was thinking. I think stateful packet inspection. Essentially, think about it this way: when we have the internet in our network, where's the good guys, where's the bad guys, right? Well, typically, good guys are here, unless you actually read some of the statistics about internal hacking, but that's another issue. Good guys are here, bad guys are out there trying to break in your network. So you think, oh, well, I just want to deny everything from the internet. We don't want internet folk coming in our network. Let's put a deny there. Well, that's great until somebody, like your boss, decides to go out there and try to surf the internet, and when Google sends information back, or Dropbox, or whomever they're trying to contact out there, sends information back, your firewall's like, no, you don't come here, and you essentially take down the entire internet connection. Well, what can you do for that? That's the stateful packet inspection. That's what this the exact command is: permit TCP established in an access list. And what that says is, if it's established from the inside out, then I'm going to allow the outside traffic back in. So that you can put a deny all statement, except for the things that are already established from an inside out connection. Fantastic. That's all I wanted to do in this nugget, was to go through the concepts of access control lists with you, understanding what they are. They're not just for access, kind of getting that big picture thought. As we now unpack the next two nuggets, we will get into standard and extended ACLs, looking at their use, syntax, and configuration. I hope this has been informative for you, and I'd like to thank you for viewing.